This lesson is over scientific notation. Scientific notation is a way to easily handle very large or very small numbers. It is written in a specific way. It has three parts. So you have a coefficient, which is just a decimal, so it could be like 6.022 or 7.25. Then you're always going to have a multiplication sign in the middle. And then your base is always 10. This base here, it never changes. It's always 10. And then your exponent. Your exponent tells you to what power it's being raised. And we'll talk more about that. But the way that it's written is always in this way. A coefficient, a multiplication sign, a base with an exponent. So given a number in scientific notation, and you want to change it to a number in standard form, we look at first our coefficient, our number, 5.34. Now, I know that this is going to be a bigger number because I have a positive exponent. We take our decimal point and we move it however many times our exponent tells us to. And since it's a bigger number, we always move to the right. So it's going to go 1, 2, 3, 4 times over. So now my decimal point's here. And you add zeros in those blank spots. So the number written out is 53,400. Same for the second example. We take 7.42, or 7 42/100ths, and we move the decimal point over 5 times. We're moving to the right since my exponent's positive. So 1, 2, 3, 4, 5. So that means there's 3 zeros that need to be added. So my number written in standard form would be 742,000. So an important thing to remember is that if a number is greater than or equal to 1, the power of 10 is positive, you move the decimal point to the right. Okay, now we're going to look at numbers that have a negative exponent. So scientific notation that has a negative exponent. The first one is 3.27 times 10 to the negative 3 power. So we start by writing our decimal, so 3.27 or 3 27/100ths, and we're going to move our decimal point to the left this time because when we have a negative exponent, our number's getting smaller. So we're going to move it to the left 3 times. 1, 2, 3. That puts my decimal point right here. Put in zeros in the empty spots. So the correct answer would be 0.00327. Same thing for the next one. We're going to start out with our decimal, 6.1. We're going to look at our exponent. Our exponent's negative 2, so we're going to be moving to the left 2 times. 1, 2. That puts my decimal point right here. We're going to put our 0. So the correct answer in standard form would be 0.061. So if we have a negative exponent on scientific notation, we're going to move the decimal point to the left. Now we're going to do just the opposite. We're going to take a number in standard form and we are going to write it in scientific notation. So we are starting with 3,725,000. We know that our decimal point is right here after the number. And so we're going to move it over until we have just one number in the ones place. Once we get that, we know that's where our decimal point needs to be because scientific notation always has a number in the ones place and then any numbers after it. So I'm going to move it over and I'm going to count how many times. 1, 2, 3, 4, 5, 6. That puts our decimal point right here between the 3 and the 7. And that's where we want it because we want one number in the ones place and then the rest will be our decimal. So when we're writing it in scientific notation, it would be 3.725 and then times 10 because it's always 10 as our base to the 1, 2, 3, 4, 5, 6. So 10 to the 6th power. It would be a positive 6 because we're going from a very large number to scientific notation. So now we're going to do just the opposite. We have a really small number, and we're going to move that to scientific notation. So our decimal point's already given right here. So we're going to count how many times. 1, 2, 3, 4. We stop here because we just want a number in the ones place, and then the rest is decimals. So that gives us 3.16 times 10, because that's always our base, and we're going to count 1, 2, 3, 4 times. So to the 4th power, but since it's a very tiny number, it's going to be -4. So 3.16 times 10 to the -4th. Please complete these practice problems in your notebook. Make sure they're on the left-hand side. If they're in scientific notation, turn them into standard form. If they're in standard form, turn them into scientific notation.